Next problem, we have dy dx is equal to the opposite of y times x plus 1. We need to move the y over, so we'll divide by y, and we're also going to move the dx over. When all is said and done, we have dy divided by y is equal to the opposite of the quantity x plus 1 dx. Could the negative sign go over? Yeah. Ultimately, it's not a big deal, but again, I would always suggest that you move as little as possible. Okay, variables are separated. Now it's time for our antiderivative. Okay, so what do we have here? Well, dy over y, that's our trigger for the natural log of the absolute value of y. And then over here, we have x squared over 2 plus x. And we're going to negate it, so we'll have the opposite of x squared over 2 minus x. All right, step 2 is done. Now we need our step 3. Don't forget the plus c. Okay, now that's done, which leads us to step 4, which is to find the value of c using the initial condition. When we plug in -2 for x, we get 1 for y. So we have the natural log of 1 is equal to the opposite of -2 squared over 2 minus -2 plus c. Well, the natural log of 1 is 0. -2 squared is 4, but then we negate it again, so we have -4 divided by 2 would be -2. And then we have minus -2, which means we're adding 2, plus c. So we can actually see that our 2's will wipe each other out, and c is equal to 0. What does that mean? It means the natural log of the absolute value of y is equal to the opposite of x squared over 2 minus x. We have to get y all by itself, so we're going to raise each of the sides up into the exponent of e. Alright, doing so wipes these two out and brings y down front. So we have y equal to, and again I can lose the absolute value signs because over here on the right I have e, and e is always positive. It's e to the opposite of x squared over 2 minus x, and we are done. As far as the domain is concerned, well again, there's our variables here, there's nothing to worry about. E to the whatever is fine, so once again our domain will be all real numbers.